And before we start, I would really appreciate it if you could smash that like button, drop me a comment, and share this free program with anyone who might need it. Hello everyone, welcome to the third series. So let us start with the 21st question. The question goes like this: when cement is tested for setting time on gauging, it shows quick setting. This phenomenon is known as flash set of cement. It is due to presence of water. The three options given here are two are Bogue's compound, one is alkali. So alkalis are not responsible for the flash set. They don't provide any setting or strength properties. Therefore, you can omit number 2 and therefore omit anything with number 2. Your answer is 1 and 3. If you want to check, if you look at tricalcium aluminate, so tricalcium aluminate, it is something which reacts firstly in a hydration reaction, and it is also responsible for the setting. And tricalcium silicate, this is also responsible for the early setting. So these two things, they react firstly when water is added to the cement. So therefore your answer is 1 and 3. Next, which of the following statements regarding cement fineness is not correct? Fine cement is more liable to suffer from shrinkage cracking than coarse cement. This is correct. Fine cement will show faster rate of hardening than coarse cement. This is also correct because they are very fine and therefore the surface area is very large. It will react very fast. And fine cement shows faster rate of heat evolution, and total quantity of heat evolved is much larger than coarse cement. This is also correct. Fine cement shows same setting time as coarse cement. This is wrong because fine cement, the setting time will be very less because the surface area of cement is more, and therefore hydration reaction will take place very fastly. So your answer is option D. Next, for marine works, the best suited cement is what? So for marine works, we will mostly go for Pozzolana cements. Pozzolana means it can either be, Pozzolanas are non-cementitious materials like fly ash, rice ash, or GGBS, which is ground granulated blast furnace slag, or blast furnace slag simply. So your answer is blast furnace slag. The reason why we are going for Pozzolana cement, pozzolana based cement, is because marine works, they will have many chemicals in it. There will be presence of salts, chloride, sulfates, etc. So in order to combat these things and to avoid chemical reactions, we will go for pozzolanic cements. So the upcoming few questions, this will be the format. Statement 1 and 2 will be given. We have to choose either of these four things. Flash set is the stiffening of cement paste within few minutes of mixing. This is true. And flash set occurs due to insufficient gypsum to control the rapid reaction of C3A with water. This is also correct. Because of less gypsum, that is calcium sulfate, the flash setting occurs. So both the things are correct. Your answer is option A, which is this thing. Next is the amount of cement paste should be sufficient to cover the surface particles of all particles for proper workability and bond. This is correct. Water cement ratio is fixed accordingly. This is wrong. So if you have looked at my mixed design ratio, you would have known that for fixing the water cement ratio, you will not look at the amount of cement paste, etc. You will just look at the amount of cement alone. So this is wrong. Your answer will be option B. Next, higher percentage of tricalcium silicate in cement results in rapid hardening with early gain in strength and higher heat of hydration. This is correct. High percentage of dicalcium silicate results in slow hardening and less heat of hydration and greater resistance to hydration. This is also correct. So your answer is option A. Next, for a given composition, a finer cement will develop strength and generate heat of hydration more quickly than a coarse cement. Correct. Reaction between water and cement starts on the surface of the cement particles, and in consequence, the greater the surface area of a given volume of cement, the greater is the hydration. So this is also correct. So you can see that reason is the correct explanation for the assertion, whereas for this question, I'm sorry, reason is not the correct explanation for the assertion, because this is also true, but it is not the correct explanation. Therefore, it is option B. Next, greater the surface area of given volume of cement, greater the hydration. This is correct. Reaction between water and cement starts from the surface of the cement particle. This is also correct, and this is the correct reason if your answer is option A. Next, a low C3A cement generates less heat and develops high ultimate strength. So C3A is tricalcium aluminate. So it generates less heat, which is correct, and develops a high ultimate strength. That is also correct. During setting and hardening, the amount of lime liberated appears to be about 15 to 20% by weight of cement. The reason given here, it is very vague, therefore we can select option C, which means A is correct but R is wrong. Next, match the types. Match list 1 with list 2. Ordinary Portland cement, rapid hardening cement, low heat cement, sulfate resisting cement. So the percentage of C3S is maximum and is of the order of 50%. If C3S is maximum, then it means that it is rapid hardening cement. And if we look at this, preserves the form of brick at high temperature. So temperature is involved here and it prevents shrinkage. So therefore I can say it is low heat cement. So if I match C with 4, these two will get cancelled, and if I match B with 1, again it is matched only. Next, if we come to ordinary Portland cement, we can see that it reacts with silica during burning and causes the particles to unite together and develop the strength. So OPC, if we know the process of making OPC, we will know that this is what that happens. So A will match with 3, therefore your answer is option B. Next, again matching list 1 with list 2. We have high strength Portland cement, super sulfated cement, high alumina cement, and rapid hardening Portland cement. Super sulfated cement. It is already super sulfated, that is, it already has all the admixtures that are needed. Therefore, it should not be used with any admixture. Therefore, this is correct. So, if I match B with 1, then A and C, D will get cancelled. Next, we have rapid hardening Portland cement. We know that it has high content of tricalcium silicate. So, if I match them both, D should match with 4. Therefore, their answer is option C. Next, the proper size of mold for testing compressive strength of cement is what? So, for testing the compressive strength of cement, we will go for a cube. So, the rule here is this surface, right? This area of the cube that on which we are going to test, we will be testing for compression. So, on which we are going to test, this area should be 50 centimeter square. That is your requirement. So if the area is going to be a 50 centimeter square, then what should be your side? You can just take square root of 50, which will give you 7.05. Therefore, your answer is 7.05 centimeter cube. Next, low heat Portland cement is used in dam construction. Low heat Portland cement attains higher 28-day strength than ordinary Portland cement. So it does not attain high strength and all. The only reason we use low heat Portland cement is because it generates less amount of heat. So R is wrong. So R is false. So the answer is option C. Next. So we have high early strength lining for canals, etc. So we know that for marine structures we will go for pozzolanic cements. So if D has 1, then I can omit C and A. I will have these both, and I know that high early strength means it is rapid hardening cement. Therefore, if I match A with 2, both is already matched with 2. So next, if I come to frost and acid resistance, we know that for less chemical attack, to be less vulnerable to chemical attack, we will go for high alumina cement. So matching C with 4, I will be having option B, which is my correct answer. Next and the last question of this series. As per specification, the initial setting time of ordinary Portland cement OPC should not be less than what? It should not be less than 30 minutes. And final setting time, it should not be greater than 10 hours. So with this, we come to the end of this lecture. In the next lecture, let us look at 15 more questions. Thank you so much for watching, guys. I'll see you in the next video. Bye.